Welcome to GAK Math Plus. In our previous lesson, we looked at theorem number 2, that is angles in a semicircle, and I gave you a trial question. Let's quickly look at the solution to this trial question. In the figure below, PR is a diameter. Angle PRQ is equal to 35 degrees. Find angle QPR. If you take a look at the shape, you will note that the angle we are expected to find is subtended at P, and the angle we are given is subtended at R. And from the theory length, angles subtended on the circumference of the circle from a diameter is a right angle. That is, the angle subtended at Q is 90 degrees. So, the angle subtended at P plus the angle subtended at R will give us a sum of 90 degrees. So, we have angle RPQ plus angle PRQ is equal to 90 degrees. Let's substitute the value of angle PRQ. So, we have angle RPQ plus 35 degrees is equal to 90 degrees. Let's group like terms. We have angle RPQ is equal to 90 degrees minus 35 degrees, and this gives us 55 degrees. So the angle subtended at P is 55 degrees. Great. Now let's look at our lesson for today. That is the next theorem, theorem number 3, angles subtended on the circumference of a circle by a chord. Let's take the proof. First of all, let's draw a circle. Then let's draw a chord AB. Let's subtend an angle on the circumference of the circle from the chord and another one to the left of it. Let's label the vertices of the angles formed as C and D. Let's label these angles as alpha and beta. Now, locate the center of the circle and label it O. Let's draw a line from the chord AB to the center of the circle and label the angle subtended at O as V. From our first theorem, we know that the angle subtended on the circumference of the circle and the one subtended on the center of the circle from the same arc has a beautiful theorem or relation. That is, 2 times the angle subtended on the circumference is equal to the angle subtended at the center from the same arc. So we can say that 2 times alpha is equal to V. Similarly, 2 times beta is equal to V. So we have twice the angle subtended on the circumference is the angle subtended at the center of the circle from the same arc. So we have 2 times alpha is equal to V. That gives us equation 1. And our equation 2 is 2 times beta is equal to V. Let's substitute V is equal to 2 times beta into equation 1. So this implies that 2 times alpha is equal to 2 times beta. This gives us 2 alpha is equal to 2 beta. Dividing both sides by 2, we have alpha is equal to beta. The relation this is telling us is that the angles subtended on the circumference of a circle from the same chord are equal. So we have, therefore, the angles subtended on the circumference of a circle by the same chord are equal. Similarly, when we have other angles subtended from the chord AB, probably R and T, the theorem is telling us that these 4 angles R is equal to alpha is equal to beta and is equal to T. And that is what the theorem is telling us. Let's take an example and look at how this theorem is applied. Example 1. A, B, C, and D are points on the circumference of a circle. Line BD is the diameter of the circle and angle ACB is equal to 62 degrees. Find the value of X and Y. Now, looking at the shape, we note that the angles subtended at C and D are equal because they are subtended from the chord AB. Similarly, if you observe the shape so well, we know that the line BD is the diameter of the circle. And drawing on our second theorem, we can say that the angle subtended at A, that is angle BAD, is 90 degrees because it is subtended on the circumference from the diameter of the circle. So we have Y is equal to 62 degrees because the angles are subtended by the chord AB in the same segment. Also, from the triangle ABD, angle BAD plus Y plus X is equal to 180 degrees because angles in a circle, the sum of interior angles in a triangle, is equal to 180 degrees. So we have our angle BAD is equal to 90 degrees and our angle Y is equal to 62 degrees. This implies that 90 degrees plus 62 degrees plus X is equal to 180 degrees. Grouping like terms, we have our X is equal to 180 degrees minus 90 degrees minus 62 degrees, and this gives us 28 degrees. Therefore, the value of X is 28 degrees and Y is 62 degrees. Great. This is how to apply on an instance how to apply the theorem we just learned. Let's now take a trial question. Pause the video and solve this question. In the diagram below, A, B, C, and D are points on the circle. If angle ACB is equal to 62 degrees and angle BEC is equal to 94 degrees, find angle ADB and angle CAD. You can follow GAK Math Class on Facebook, YouTube, and WhatsApp. Our link to this video will be posted on WhatsApp anytime we release a new one. Don't forget to like our pages, subscribe to our YouTube channels, and share the videos when you have them. Thank you.